This work focuses on brushing techniques that are used for selection in large datasets. Brushing techniques have a long history, with the first interactive selection tools appearing in the 1990s. Brushing techniques can be used to avoid occlusion, overplotting and overlapping during data selection. Selection is especially difficult in large datasets where many visual items tangle and create overlapping. Such techniques help to visually select items of interest with interactive paradigms, that is, pan or zoom in a view. These techniques, which are part of the standard InfoVis pipeline for visualization and exploration, are now standard interaction techniques in visualization systems and toolkits. Since then, many additional techniques have been developed to address selection accuracy and flexibility issues. Here are examples of existing approaches. Some works try to select multiple items by brushing an area. The obtained items can then be removed or placed in another view, specifically designed for this purpose. Some other works tried to manipulate the joysticks in a virtual reality environment to select the items. In our approach, we propose filtering trajectories by taking into account the shape of the brush in addition to the brush area. This dual input is providing at the same time and opens novel opportunities for brushing techniques. Here we take an example of many aircraft in the France aerospace. As for any interactive system, user input plays the main role and will operate at every stage of the data processing. Given the dataset, the user inputs a brush where the algorithm extracts the brushed items. The cornerstone of our technique relies on a shape comparison algorithm. This algorithm must provide a numerical similarity measurement that is ordered, high score for correlated shapes, continuous, no steps in the computed metric, and with a semantic so that the user can partially understand the logic behind this similarity measurement. Functional data analysis is a well-known information geometry approach that captures the statistical properties of multivariate data functions, such as curves modeled as a point in an infinite-dimensional space. A simple analogy can be drawn with the principal component analysis (PCA) algorithm where eigenvectors and their eigenvalues are computed. The algorithm stores the brushed items into bins. Items can then be sorted in continuous ways from the less similar to the most similar ones. Each bin is then used to visually show the trajectories it contains. Here we use 5 small multiples, which gives a good compromise between visualization compactness and trajectory visibility. The user can then interactively filter the selected items with the range slider on top of the small multiple visualizations. The Pearson's correlation (PC) is a statistical tool that measures the correlation between two datasets and produces a continuous measurement between -1 and 1, with 1 indicating a high degree of similarity, and -1 an anti-correlation indicating an opposite trend. The approaches can also be used in detecting patterns in eye-tracking scan path. For detailed information, please see the manuscript.